Good morning, everyone. My name is Armand Mohan, and I'm from Langkawi. I'm studying in KDU Glenmarie, which has completed my mechanical engineering degree. All right, so I'll be speaking today about a more sustainable disc brake component. All right, so as we all know, due to the increased population growth and the demand for agriculture and manufacturing has increased over the last decade, the last 2 to 3 decades, which has led to a massive increase in greenhouse gas emissions, unsustainable energy use, as well as deforestation, which we have all seen over the last few years has caused massive impact on the planet. So now, for this case specifically, I conducted a project on a more sustainable way of using disc brake or brake pad components in automobiles. So the automotive industry have had a massive impact on the environment in the last 50 years due to the amount of energy required to produce and run some of these vehicles. So I'm going to talk more about the brake components of an automobile, which includes the disc brake and the brake pad. Okay, so most cars use ceramic fiber. Most cars in general actually use grey cast iron. So, but then more high performance cars use matrix simulation, carbon fiber, these kind of things, which are all synthetic material and are all unsustainable in the long run. So, and in terms of brake pads, most cars use asbestos as well as ceramic and Kevlar, which are also all synthetic, and it requires a lot of energy to produce them, and this energy is produced, since they are produced from petroleum, coal, they are unsustainable. So I'll be talking about one of the main project scope here is to study, develop and analyze the mechanical properties of a more suitable natural fiber composite that could be used as a potential replacement for the asbestos-based brake pads in automobile industry. So now, of course, the composite would have to be analyzed for its tensile and impact strength after choosing and doing proper relative study. The fiber chosen for this study would be KNF fiber due to its relatively good thermal dissipation. It's got good heat absorption, and then it's got very good thermal properties. It's got very good frictional properties. It's got very good strength. So we're going to analyze the mechanical and impact strength for KNF fiber composites. So the process done to carry out this was the hand layup method. So the hand layup method is done layer by layer. We put in using epoxy resins. We'll do it layer by layer with different configurations. Another synthetic fiber which was used was glass fiber. Glass fiber has good mechanical strength as well to give it a potential reinforcement. So it was done with different configurations: 100% KNF fiber, 50% glass fiber, 100% glass fiber. So it was done according to the respective ASTM standards, Shimadzu Universal Tester for the tensile test, as well as Shimadzu Chapi Impact test carried out for the impact test, both of which were used using the Shimadzu Universal testers. So now we had different configurations: 50%, 60%, 60-40, 50-50 for KNF and glass fiber respectively. After conducting the hand layup method and the testing and all these, we found that the results showed relatively good potential in terms of the 100% KNF fiber in terms of tensile strength. So it showed very good tensile strength potential. And for the 50% KNF and 50% glass fiber, it showed very good impact strength. So a lot of discrepancies could be there due to hand layup method. A more general procedure needs to be done, more experimenting and testing needs to be done. So overall, natural fibers is the most sustainable way to go. So therefore, I believe that the potential implementation of these natural fibers as brake pad material can lead to a way more sustainable method of living. So with more further research and studies and testing and experimenting done, I do believe that natural fiber composites such as KNF and many others, in fact, have very good potential to be used as brake pad components just as starters. We are living in an environment where anything we do to replacing it from an unsustainable manner to a more sustainable manner does help, even though in small terms. So I do hope that more research can be done, more testing, more analyzing can be done to see the usage of natural fibers, composites as a potential replacement for brake pads in the automotive industry. Thank you very much.